Okay. Good afternoon, everyone, and welcome to the afternoon session of today's session, which is more on the social sciences in the landscape decision context. So we've got 4 speakers today in the afternoon, starting with Lex Comber from the University of Leeds, who is, what are you again, Lex? You are a professor of spatial data analytics. And we shall be followed by Professor Susie Moat from Warwick Business School, who's a professor of behavioral sciences, after which we'll go to break and then have the speakers after that. So without any further ado, Lex, take it away, please.
Okay, I'm going to try and share my screen and we'll go to that. Okay, can everyone see that? I'm assuming you can. Okay, well, thank you, Felix, for the introduction. My talk today was on key considerations for integrating quantitative social science with landscape decisions. I think I've rewritten this talk twice over the last couple of days, just based on what people have been saying and you know, and the feedback for, and the other talks. And so I'm not quite going to give the talk I thought I was going to give, and I'm not going to give the talk that is kind of described in the abstract. In a way, I think one of the things that's come through in previous talks is this need to think about data and to think about the kind of spatial properties of data and also the semantic properties that came through a little bit with Gary. And also alluding to things like Paula introduced this idea of kind of having, you know, sort of, model coupling and the need for kind of modeling coupling frameworks. I think there's probably a need to think about data coupling frameworks as well. I'm going to just move my slides on. I'm going to give you my summary. I'm going to say that care is needed in linking social data, especially if that relates to preferences. I'm going to demonstrate that small changes in preferences result in very large differences in outcome. I'm going to talk about social data, and I'm going to illustrate some of the dynamics of social processes, and the range of data there are for capturing social dynamics and social processes. And I'm going to just briefly talk about formal data. So this is census data or targeted survey data, which can be comprehensive. But I'm also going to talk about some of the more informal data that we're increasingly seeing in analyses and in of different kinds. And I'm going to make an argument that the formal data is typically out of date the moment it's released, and because of its temporal static nature. And I'm also going to show some of the kind of biases, the huge biases that are there in crowdsourced data and, you know, data scraped from social media and so on. But they can be linked to overcome this. I'm going to make some suggestions. Felix introduced the MORP on day 1, but I would actually say you slightly misspecified it, Felix. And I'm going to argue that the MORP should be routinely tested for. It's a massive and overlooked issue and affects all spatial data. We should be looking to always describe or understand how our models are affected by the MORP. I'm going to argue or make some points around essentially not believing the hype around big data. There's been a number of recent research papers that have kind of shown how small targeted data sets are better than a big data shotgun, and that we shouldn't necessarily be approaching you know, n equals all, where the number of observations we have starts to approach the population without targeting that data. As I've said before, I think we can integrate formal and informal data to capture social processes, and we can apply data transfer functions and not just model transfer functions within model coupling. I'm just throwing this in now. I'm not really going to talk about this, but maybe we need to think about dashboards rather than static models, which allow dynamic, exploratory and flexible approaches to understanding the impacts of our data choices. and I'm going to advocate a critical approach to all analyses of spatial data and informal data, linking to a recent paper. I won't describe this now because I'll buff on at the end. Okay, so originally this is what I was going to talk about. The invitation was to talk on geospatial quantitative social science, and really what I thought about was how do we get people into the landscapes? How do we start to understand social processes, behaviours and preferences? And really then my original aim was to kind of look at how different actors with different objectives make different kinds of landscape decisions, looking at the variation in preferences within and between groups and tensions between individual and institutional objectives. And through this then to explore methods for understanding the uncertainties associated with those. And this was going to be my kind of slide. I was going to focus on a classic ecosystem services approach, using a kind of elaborate case study, and try to work through the different areas of uncertainty associated with this diagram. But, and alas Stan Openshaw, a nice big but, there are, I think one of the things that's come through days 1 and 2 is the need for a number of data and spatial data issues to discuss. James Skates highlighted the importance of data and model inputs. Felix touched on spatial issues with the MORP. Paul, as I mentioned earlier, mentioned model transfer functions, but what about the data transfer functions? And I think if you're going to put people into the landscape, one of the things that has come through in the talks is that actually the social processes are quite dynamic, but the data are not. Okay, and so I think some of these considerations are kind of often overlooked, and I will provide an illustration of them more. Okay, so where do we get our quantitative social science data from? The classic approach is to go to the census, when we can download or equally a number of kind of attitudes and preference surveys. These can be obtained from a number of sources. There's the ESRC social surveys data sets, the census data, and so on. And we can use these to parameterize things like ABMs or as inputs into our allocation models and so on. But we've also got a whole load of new forms of data, and really this kind of captures what people say and do. And if you look at somewhere like the CDRC at Leeds, then you can access some of these data sets, store loyalty cards. We can all download and scrape social media. We can link to cell phone movements and Oyster cards, automatic number plate recognition, etc. But they both come with their own caveats. So we think about classic social science data. We've got this is data sets for Liverpool, just showing kind of 3 variables. On the left, we've got the percentage unemployed. In the middle, we've got the under 45-year-old percentage, and on the right, we've got the percentage green space. So classic kind of spatial data. There are different frameworks we can use with different granularities. And so again, on the left, we've got output areas, which kind of typically cover about 300 people. And on the right, there are lower super output areas, which cover about 500 people. And we can use these to link data, such as the data set in the middle, which is actually a house price data set that we scraped from Nestoria last year to actually as part of writing a book, the data set for the book. So if we wanted to understand house prices, we could link the price of houses to data, to census data, and examine the factors associated with variations in house prices. And we've got a choice about whether we want to use that data over small areas or slightly larger areas. And as I'll illustrate later, that choice has profound impacts. Okay, so classic social science data is easy to get hold of. There's a whole load of portals. There's a CDRC, the Consumer Data Research Centre. We've got the UK Data Service as well, hosting the ESRC's data. And there's other portals as well, like the Police Crime API and so on. And we can set up workflows to pull this data down either into our models or dynamically into our dashboards. Well, and there are also lots and lots of new forms of data. So we can go and get Oyster card data from Transport for London. We can look at spending data from bespoke data sets, and we can do things like we can pull down social media data to try and understand people's preferences and their choices. Okay, and this is all equally easy to do, and again fits into workflows and automated pulling down of data. Now, we can use these to put people into the landscape, okay, and we can start to think about, if we wanted to think about some ecosystem processes, we could perhaps look at supply and demand. How do we facilitate access to green space? We can use these as weights for some kind of modelling. But their use is problematic as well. And if we were to just look at some kind of preference or something like this, we can see that there are large differences between different data sources. So I'm just going to have a quick look here. Okay, so let's just, I've got a small example with some data being wrapped into a tool, and you can use, I have got the full model which can be used in an exploratory way. And this is really just something, I didn't dare do it live, but this is a front end to a kind of, I suppose, decision support system, would you call it? This is a kind of a dashboard front end to a whole load of R code. And essentially what it does is I've got two kind of tables of preference, okay? And I'm going to use those so these are the weightings that I've highlighted that are given to, let's say, cultural ecosystem services from two land uses. And all I've done is, these broadly come from the literature, and I've perturbed one of them just by changing the weights given to two land uses in one ecosystem score. And so we've got this current land use at the bottom, and all I'm going to do is rearrange that whilst not moving broadleaf woodland and not moving urban areas. And I'm going to try and kind of identify a kind of perhaps a more satisfactory arrangement of land use, different land uses. But I'm going to do that with some underlying surfaces that say something about the strength of the underlying environment. So the provision and ecosystem service might be soil fertility. The cultural ecosystem service might be distance to urban area. The regulating one might be soil moisture, and so on. Okay, so I can run this and generate some some Pareto optimizations. And I'm just examining the two most extreme ones, in the cultural services. So all I've done is, obviously with Pareto set, you get what Peter called a kind of equally optimal set of solutions, and I've just picked the two that are out at the tails of the ecosystem, cultural ecosystem services. And just very small changes in these weights results in very different outcomes. Now, it's very easy to understand why, because essentially the relative weights between cereals and grass have changed, but also between cereals and other crops and oilseed rape maize and beans in the second version. My point being is that a very small and seemingly minor change in preference will result in very different outcomes in some kind of allocation exercise. Okay, so I mean that was, in a way, I was going to talk around all of this graphic, and was going to be examples for all of these. I've just talked around the scores and weights issue. But I equally could have talked around how the gradients are generated. I could have talked around what happens if you use the field parcels or a 200-meter pixel, or if we started to bring in ownership boundaries and things like that. But actually, I felt it was more important to talk around some of the data issues. Okay, oh well, I've pretty much summarized that in the slide. So yeah, I suppose that this is a very simple example, I suppose these kind of the differences in outcome will get more, will get larger as the complexity of the models increases, with more detailed land uses, with the full, actually this, what I've shown you is a subset of a national model. And, you know, so as the geographic scope of the study area increases, and I'm only using 3 ecosystem services, you know, what happens if you were to put all of those in? Okay, so that was what I was going to talk about, but I cut it down. But I really wanted to talk about social data. You know, I think one of the issues with census data, which is typically how we get an understanding of people, is that they're out of date as soon as they're released. Typically, census data takes 2 or 3 years to come out. It tells you where people sleep and not where they live the rest of their lives. And there are other data sets you can use. Workplace zones and commuting patterns are captured by the census. So we do have an understanding of where people spend their time in the day. And Dave Martin's group at Southampton have done some fantastic work looking at 24/7 work, looking at the changes in population in locations for each hour of the day, for each day of the week, through the year, and so on, taking into account holidays and work patterns and you know, I mean, and then that data set can be used to manage all kinds of things. But it's still out of date. And we can get annual updates for certain activities, and you know, that we can use these to kind of update our social data. And I've just given a big list here. This is some work being done by one of my PhD students, looking at geodemographic trajectories and how we can capture social processes and their dynamics. And you know, if I think about the area I live near in Nottingham, the social processes are very deep. Areas that were, you know, that were scumbag and run down when I bought my house cheaply now have started to become quite gentrified. So, and these processes happen over very short time frames. So capturing the dynamic nature of social processes is really important and is problematic because our data are temporally static. As an indication of this, this is some work just again looked by my PhD student looking at geodemographic changes, and geodemographic classifications are essentially small area pen portraits of the properties of the characteristics of the people that live there. And you know, just you know, we could, this would be although the graphic is for Leeds, the table is actually for Sheffield, and we're just looking at the intercensal period there, looking at the annual reassignments that you would do if you were doing this each year. So essentially, there's around 3% change every year, but obviously over 10 years this stacks up. So I'm not sure about the cumulative percentage. That's another question. But essentially, there are large area changes in any given year in the characteristics and properties of the areas over which census data are reported. And I think to ignore this is a bit dangerous. So there are also, you know, we can also go and think about these new forms of data. You know, we can try and overcome some of the census limitations with data that captures kind of information about more rapid social processes. And we can think about how some of these data sets can be used and whether they're used, whether they're the kind of more social media ones or whether they're data that are emergent from you know, sort of increasingly instrumentized agricultural practice, whether that's field sensors linking to remote sensing, or etc. But these are, you know, many landowners are routinely kind of capturing this kind of information. So what about the opportunities for these? Well, they have the potential to offer huge insights. Again, other PhD students I've been looking at how we can use sort of tap in, tap out data for Oyster cards, how you can use sort of bike rental data sets to kind of predict demand. I've got another PhD student whose papers are just getting published now, who's actually capturing the impacts of COVID on green space usage. He didn't intend to, but he collected the data over the COVID period and the changes in activity captured through Twitter data are just incredible. And so we're actually thinking about refocusing his PhD a little bit because he's in his first year. But these data exist in rural areas as well. As well as kind of capturing information about where people live, you know, you'll get most social media data where there are most people, but these data exist in rural areas as well if you know where to look. However, there are huge potential problems with using with new forms of social data. They obviously have huge biases, and we are, and Cathy O'Neill, I'd recommend, I'll put a link at the end of the talk to Cathy O'Neill's TED Talk, and I recommend anyone who's thinking of kind of using some of this big data to have, you know, to sort of watch that. And we've seen some of these things come out in recent times with all of the exams kind of models that were put together and then unconstructed. And the basic issue is this is data that hasn't been collected under experimental design, which then results in kind of gaps and biases and so on. Okay, and I think, you know, there's a nice bit of work by Meng who compared you know, the utility of, and essentially the veracity of analyses that were undertaken using a very small data set, but it was targeted with a 60% response rate, with a very large data set covering 80% of the population. And essentially, the smaller targeted data was better than the bigger untargeted data. And I think this is a kind of key lesson for anyone who's thinking of using social media data or other forms of new data in their analyses. You really have to understand the biases in them. And I think it also suggests the need to take a critical approach, and that's the slide I skipped at the front. I'll return to that at the end. Now, I couldn't let Felix's talk about the MORP go unmentioned. The modifiable area unit is a long-standing, well-known problem in population geography, although, and it's quite simply, it says that if you aggregate your data over different spatial units and then do some analysis of it, you will get different answers, and you will get different understandings, and you will get different relationships. And if you're then going to pass these into models, you need to be aware of the sensitivity of your statistical or other model to those distortions. And it applies to all spatial data. Stan Openshaw, who's still with us but has not been active for about 20 years since he had a stroke, is actually one of those rare geniuses whose work is still very applicable. And I suggest you go and look at some of his papers. He has kind of done lots and lots of work around spatial data that we're still kind of going, that paper really applies now. We're still finding nuggets in it. So just to illustrate the MORP, Felix used a kind of a forest and I think it was crop aggregation model over different spatial units. I've taken my Liverpool data that I showed you earlier, and I've made two simple regression models. I used the same population counts for Liverpool. So there was a few, the proportion of green space area, but the population counts were the under 25s, under 45s, under 65s, and over 65s, and unemployed. Okay, and so the same number of people, but obviously when you generate proportions over different areas, you get different over different geographical units, you get different numbers, but the same data essentially. And these are just the coefficient estimates from a standard regression model. And I've just highlighted two that would, and they're linked to this house price data set. And they would give you very different understandings of, of the relationship between the proportion of people who are under 25 and that relationship with the price of a house. In both cases, nearly doubling. Okay, so there's, for each increase of 1% of the proportion of under 25s is either associated with a £2,000 increase in price or a £3,000 increase in price. These are huge, if I'd looked harder, I could find you an example where those coefficient estimates, the sign of them would flip from negative to positive. The MORP is a bit of a pain. It's non-linear, non-nested, non-hierarchical, and difficult to predict, okay? And I've just listed a couple of examples there, but I think it should be examined if you're linking models. I'm conscious of time, so I'm going to try and wrap up now. I'm going to talk about things I haven't mentioned. Gary mentioned semantics. What is a forest? Sorry, Gary, I've got a slightly more practical example. These are all real examples of data that are mapped in forestry or not. And really understanding the semantic and ontological aspects of data is critical before putting it into the models. I'll just point out one thing. In the right graphic, you've got the same organization, United Nations, in its forest resource assessment in 2000, and UNESCO having different definitions of forest. That's interesting. There are methods for dealing with these, and I've just given one based on concept lattices, but there are other approaches as well. And I've just put some of my old papers. This is old school stuff. We did what Robin Fuller at CEH said you couldn't do, which was link the 1990 land cover map and the 2000 land cover map to get sensible things out of it. It can be done. You can work with this. And this was data driven, not expert driven. And I think some of the issues around VGI here, there are huge differences in the way that people see the world. That's basically what this says. And this plays out when you kind of start using that data as inputs into models. So this was just some land use data captured by GeoWiki, and essentially there are different concepts of like bare ground, of forest, shrub, etc., amongst different groups. Okay. And someone mentioned, Tobler's law was mentioned this morning, and I just thought that just got me thinking about, well, there's also, you know, many of the kind of social processes we investigate are subject to spatial non-stationarity, which means one size fits all models, statistical models don't always work very well. So there's a need potentially to move from whole map models and statistics. Okay, so I'm running a little bit late. I think we need to think very carefully about how we link social data into our landscape decision models. Small changes can result in large differences in outcome. Capturing social processes and dynamics is important, and I think linking some of the new forms of data to classic formal data is a way of doing that. And why am I saying all this? Because a few years ago I wrote a paper, and there's some parallels here around the wider availability of spatial data. I kind of was doing some paper on location allocation for supply for bioenergy, and I went into the literature and the energy literature, and I was horrified by the inappropriate use of very powerful tools that had been wrapped up into commercial software. And to be honest with you, out of 50 papers I reviewed, I think there were 6 or 7 that had used the tool for the problem in the right way. So what I think the point I'm trying to make is that spatial data are everywhere, and I think geography, we have something to. We have a deep understanding of these issues because we've been working with them for a long time. But you know, so don't assume that your domain knowledge gives you spatial data knowledge. Okay, so we should test for the MORP all the time. Don't believe the hype with new forms of data. Think about dashboards and take a critical approach to your analysis. I'll leave this slide up. I have got some other ones as well, but I'll just come back to these. Okay, thank you.
Thank you very much, Lex. We don't have we've got one question, and we're just at 2 o'clock, so I'll just quickly put that one up. It's come up from SM Labib, who has said, I'm just wondering, are the COVID-19 impact of green space used from Twitter data geotagged, or are these tweets just expressing how people use green spaces during lockdown?
So what we've done is we've got historical data of Twitter data for London, and we've been collecting data in COVID times. They haven't had explicit COVID tags on them, but they are all geolocated. So that in itself is a bias because there's only a small proportion of tweets that have data in them. But our reference data set is also geolocated. So And what we can see is very, very different patterns of usage and sentiment in and around green spaces in London.
Very interesting. Yeah. I guess where we, yeah, we probably should leave it for there. Okay, thank you very much, Lex.